Pleasant Fractions Problem
by Franklin Yeh
and Lorenzo Calvano. 3 properties of pleasant fractions. 1. The fraction is greater than 0. 2. The denominator of the fraction is 4 more than the numerator. 3. Subtracting 1 from both the numerator and the denominator of the fraction forms a new fraction that is at least as large as the reciprocal of the numerator of the original fraction.
Property 1. The fraction is greater than 0. This tells us that the fraction overall is positive, meaning that the numerator and denominator are either both negative or both positive. Students often overlook that both the numerator and the denominator can be negative, as it is easy to forget and think that a positive fraction has no negative values when unsimplified.
Property 2. The denominator of the fraction is 4 more than the numerator. X equals the numerator in a pleasant fraction. This property tells us that x over x plus 4 would be the fraction based on property 2 standards. This is because if the numerator and the denominator were the same, an example of this would be x over x. However, because the denominator is 4 more than the numerator, and we don't know what the denominator is, other than in terms of the numerator, we choose to have the variable be the numerator. If one wanted to have the denominator as the variable x, then the fraction would be x minus 4 over x. Both mean the same thing, but we would choose to use x over x plus 4 in our explanation.
Property 3. Subtracting 1 from both the numerator and the denominator of the fraction forms a new fraction that is at least as large as the reciprocal of the numerator of the original fraction. X equals the numerator in the pleasant fraction. This property states that mathematically, including property 2's deductions, that x minus 1 over x plus 4 minus 1, which is subtracting 1 from both the numerator and the denominator of the fraction, forms a new fraction of x minus 1 over x plus 3. This new fraction has to be greater or equal to the reciprocal of the numerator of the original fraction, which means that x minus 1 over x plus 3 is greater or equal than to 1 over x, the reciprocal of x.
By putting all that we know about the properties together, we conclude that the fraction x over x plus 4 is positive. Also, from property 3, x minus 1 over x plus 3 is greater than or equal to 1 over x. This is displayed in our fraction below. For the equation, we start with x minus 1 over x plus 3 is greater than or equal to 1 over x. This is what we got from property 3. We need to solve for x with cases for x's value because we need to multiply by x and x plus 3. Multiplying or dividing by negative numbers switches the greater than or less than sign on inequalities. So we're going to test how many times we need to switch the sign for each x value range. To start, we need to know that x cannot equal negative 3 and x cannot equal 0 because it would make the above values undefined. First, we look at the denominator x plus 3 for x minus 1 over x plus 3. To make the denominator a positive value, we know that x needs to be greater than negative 3, so that it's greater than 0. To make the denominator less than 0, to make it a negative value, we know that x needs to be less than negative 3. So there are 2 cases. The same logic is used for x as the denominator of 1 over x. Since to make the denominator greater than 0, x has to be greater than 0, and to make the denominator less than 0, x also has to be less than 0. With this information, we can summarize the 4 cases into 3. Case 1 would be where x is less than negative 3. In this case, both denominators of the inequality would be negative, so we will watch for switching the inequality sign each time the denominators are multiplied. Case 2 would be a classification of cases 2 and 4, where x is less than 0 but greater than negative 3. This range of values will flip the inequality sign once when multiplying by x. Finally, case 3 would be where x is greater than 0, and because both denominators would be positive, there will be no sign changes. However, cases 1 and 2 conflict with other properties. Properties 1 and 2 conflict with them, as any value greater than negative 4 and less than 0 create a negative fraction for x over x plus 4. So, case 2 will not be tested, as it already doesn't work, and case 1 will be altered to x is less than negative 4, because it follows x is less than negative 3 under the constraints at properties 1 and 2. There are now two cases. 1, where x is less than negative 4. As we start with x minus 1 over x plus 3 is greater than or equal to 1 over x, we multiply both sides by x to get rid of 1 over x's denominator. X is negative, so we flip the sign once. After this, we multiply both sides by x plus 3, and switch the sign again, because it's also negative. We now have x squared minus x is greater than or equal to x plus 3, which we can now solve by using the zero product property. We get that x minus 3 times x plus 1 is greater than or equal to 0. This part we need to be very careful on. Since we know that both x minus 3 and x plus 1 are negative, then we know that we have to flip the sign once more when solving for x, as we are dividing one of the two negative values, either x plus 3 or x plus 1. When we do this, we get that x is less than or equal to 3, or x is less than or equal to negative 1. Under case 1's constraints of x is less than negative 4, the final answer for case 1 is that x is less than negative 4. As x is less than negative 4 doesn't entirely fit into x minus, x is less than or equal to 3, and x is less than or equal to negative 1. But both of them fit into x is less than negative 4.
Now in case 2, we solve where x is larger than 0. We don't flip any signs, as both the denominators are positive. To get rid of both denominators, we multiply them both on both sides to get, again, x squared minus x is greater or equal to x plus 3. Using the zero product property, we get that x minus 3 times x plus 1 is greater or equal to 0. We don't flip the sign like we did last time because both values were negative in case 1. We get that x is greater or equal to 3, or x is greater or equal to negative. Only x is greater or equal to 3 fits into the case for x, and that is case 2's answer. Our final answers are that x is greater or equal to 3, or x is less than negative 4.
Now that we know all real values of the numerator of pleasant fractions, along with their given properties, we can answer 3 questions. Problem 1 asks, among all pleasant fractions, is there one with a smaller numerator than any other? If there is one, what is its value? The answer to this is no. There is no pleasant fraction with a smaller numerator than any other, because one of the values for the numerator x is that x is less than negative 4. Therefore, x could have an infinitely negative value. Problem 2 asks, among all pleasant fractions, is there one with a larger numerator than any other? If there is one, what is its value? Like problem 1, the answer to problem 2 is also no. This is because another range of values for x is that x is greater than or equal to 3. Because of this, the numerator could have an infinitely high value, so there is no numerator larger than any other. Problem 3 asks, among all pleasant fractions for which the numerator is positive, is there one with a smaller numerator than any other? If there is one, what is its value? This question is asking what the smallest value for x would be if there is an x value greater than 0. Because there is, as we determine that all values greater than or equal to 3 work as numerators, the answer is 3. To remind ourselves why x cannot be in between 3 and 0, we remember that 3 is the value that makes x minus 1 divided by x plus 3 equal to 1 over x, meaning that it's the smallest positive value that makes it greater than or equal to 1 over x. Therefore, any number smaller than 3 and greater than 0 for a numerator would make x minus 1 over x plus 3, property 3, smaller than 1 over x.